What if I told you that time travel is real? Not science fiction. Real, proven science. And it all began with one man and one impossible idea about a beam of light. In 1905, a young Einstein asked a simple question. What would you see if you could chase a beam of light? The answer would shatter our understanding of reality. He discovered that light always travels at the same speed, no matter how fast you chase it. But if the speed of light can never change, then something else must. And that something is time itself. Imagine a clock made of light, bouncing between two mirrors. Put it on a speeding train, and to someone standing still, that light must travel farther. So the moving clock ticks slower. Time literally stretches. This sounds impossible, but it's real. The faster you move, the slower your time runs. We've flown atomic clocks around the world on airplanes, and they return disagreeing with the clocks on the ground by billionths of a second, exactly as predicted. Your GPS proves it every single day. The satellites overhead move so fast and sit so high in Earth's weaker gravity that their clocks drift from ours. Without Einstein's corrections, your navigation would be off by miles within a day. Now here is where it becomes time travel. Fly a spaceship near the speed of light for just a few years, then return home. For you, only years have passed. But on Earth, centuries could be gone. You've traveled into the future. 10 years later, Einstein went even further. Gravity, he said, is not a force at all. Massive objects like the sun actually bend the fabric of space and time, like a heavy ball sinking into a stretched rubber sheet. The planets don't orbit because they are pulled by a rope. They orbit because they are rolling along the curves in this invisible fabric. Space tells matter how to move, and matter tells space how to bend. And that curve slows time as well. The stronger the gravity, the slower time flows. Near a black hole, a single hour could pass for you, while decades quietly vanish for everyone back home. So traveling to the future is not a theory. It is a proven fact. But what about the past? Einstein's equations allow strange shortcuts called wormholes. Tunnels that could, in principle, connect two different moments in time. The catch? A wormhole would need a strange form of exotic matter we have never found, and it might collapse the very instant you tried to cross. So the future is open to us, but the past remains one of physics' greatest mysteries. Would you travel through time? Tell me in the comments. See you in the next one.